Righto, we're looking at questions 9 and 10 from the 2015 Standard Level Time Zone 2 paper. And firstly, question 9. Okay, what have we got here? We've got a machine manufacturing a large number of nails. The length of a nail is normally distributed where L, being L representing the length, this means is distributed normally with a mean of 50. Right, this is a mean of 50, and this is the variance. So the standard deviation is just the sigma, variance sigma squared. So this is just how it's represented, but that's our mean, that's our variance. Righto. So find the probability that that L lies between 1 standard deviation less than 50 and 2 standard deviations more than 50. Now for this, you can just make up whatever value you want for the standard deviation and plug that into your normal CDF calculation, and that'll work. So let's look at question part A to start with. It's worth 3 marks. Okay, so what I always like to get a little bell curve. I think I like drawing bell curves, but alright, we've got 50 here. I don't know what the standard deviation is, but it doesn't really matter at this stage. This is 1 standard deviation. Alright, so it's 50 plus. And this is 50 plus 2 standard deviations, and down here is 50 minus the standard. You get the idea. Now we want to know what the probability that lies between here and here. So 2 plus, so all this. So 1 below and 2 above. So what would that be? Well, we can work this out by just putting in any value for our standard deviation. So let's say, and make it easy, standard deviation equals 10. Let the standard deviation equals 10. Then we're going to find the probability that x lies between 40, right? 40 and 2 above, which is 70. So we go into our calculator, we hit menu 5, 5, right, to get in there. Normal CDF is 2. That didn't work out. Something happened there. Menu 5, 5, 2. Our lower bound. So I'm just saying our lower bound is going to be 40. Remember, you can choose whatever numbers you like here for the standard deviation, 70, but then you just put it in here, don't you? 50 is our mean, and our standard deviation is 10. All right, and that allows for 1 below and 2 above. Tab across to OK, hit enter, and we get 0.819. Okay, so let's lock that in as a value. So this is equal to 0.819 to 3 significant figures, and that's part A done. Righto. Now probability that the length of the nail is less than 53.92 is 0.975. So now they give us the area. They're giving us the area. That means inverse normal when they give the area. So let's draw a little diagram, because you know how I like to draw diagrams. Oops. Alright, so oops again. Alright, here we go. 0.975. Right, so we've still got 50 here. Now, what are they saying? 53.92. So down, so 53.92. Let's say it's there. It's 0.975. The probability. That means that the area under the curve from the left all the way up to 53.92 is equal to 0.975. We want to know what the standard deviation is. Okay, well this is where we use the standardized normal. Okay, so what we want to do is we want to transfer this across to a standardized normal curve, and you'll see in a moment how useful this is. Mean is 0, standard deviation is just 1. So, right, so that means that it's beautifully arranged here. So that's -2. Alright, so if we get a Z score, let's get a Z score, a Z conversion for 53.92 with a mean of 50 when this area equals 0.975. So what we're going to do is go in and find our Z score. And this is how we do it. So go in, we go to menu 5, 5, 3 for inverse normal. Now I know my area is 0.975. Remember, area is from the left, from the left tail. Now I'm going to leave these as it defaults to our z-score. So we just tab, 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 hit enter, and we get 1.95996. 1.95996. That's the z-score for 53.92 given that the area is 0.975. The area is 0.975. So that's my z-score. Righto. So how are we going to use that? Now z is equal to my my score minus mu, which is the mean, over the standard deviation. This is what we're trying to find. Now my z-score I've just found is 1.95996 is equal to my x is 53.92, my mu is 50, and my standard deviation is what I'm trying to find. Work that through, you get 2.00004, which is equal to what they're asking us to find. Show that sigma is equal to 2.0023 SF. Okay, z-score is really important. Standardized, normal. Okay, mean 0, standard deviation 1, using this, and inverse normal. All right. Whenever they give you area, use inverse normal, and you might be standardizing sometimes. In this case, yes, because we don't know. We don't know what in this case, the standard deviation is. All nails with a length at least t millimeters are classified as large nails. Right. At least t. Right. So a nail is chosen. Find the probability that it is a large nail. Sorry, the probability it is a large nail is 0.75. Find the value of t. The probability it's a large nail is 0.75. They're giving us the area again, aren't they? So, all right, let's have another look at a bell curve. The probability it's large is 0.75. So that's 50. The probability it's large, if we're going to say that this here is 0.75, that's a 7. All right, and then we want to, this is t here. If they're saying the probability that it's large is 0.75, we want to find out what t is. This is 50. I know what my standard deviation is now. So what are we going to use? We're going to use inverse normal again because they give us the area. So inverse normal when area, so use when area is given. Right, that's a real note, that's a tip. Use it. So 0.75, let's go back in here. Let's go menu 5, inverse normal. Area is 0.75. Is it 0.75? Let's go back. 0.75 is to the right. So actually we want to put 0.25 in there, don't we? Because that's going to help us with t. We're getting 0.25 because it's the area from the left that we're interested in. So 0.25. Our mean is 50, and our standard deviation is 2.00004, and we tab down to OK and hit enter, and we get 48.651. So therefore, what we've used is inverse normal, right, which is menu 553, and we've put in 0.75 as our area, 50 as our mean, 2.0004 as our standard deviation. So because we know the area, we use inverse normal. That then tells us what this value here, t, is. So t is therefore equal to, I've forgotten what it is, 48.651. 48.651. So we are asked for the value of t. Find the value of t. So we're going to say that is 48.7. Therefore, t is equal to 48.7, in this case, meters. Okay, so we found out what t is. A nail is chosen at random from the large nails. Find the probability that the length of this nail is less than 50.1. Right, so let's now think about this. A nail is chosen at random from this group of nails here now, the large nails. What's the probability that it's less than 51.1? find probably the length of this nail is less than 50.1 millimeters. So this here, right, we're going to put 50.1, where we want to know where, we want to know what this is, because the probability that it's between 50.1 and 48.651 will be that area there, and we calculate that using just the normal CDF, and we'll put that over the sample space, which in this case is 0.75. So we're going to go into normal CDF. So I'll show you what that's about. Menu 552. The lower bound is 48.651. Our upper bound is what was it? 50.1. Was that what they? 50.1. Yep. 50.1. Our standard deviation is 50. Our 2.00004. We hit enter. Oh, tab that across. Enter. 0.269938. So this area in here is equal to 0.269938. That's that area there. All right. Now we're asked for if a nail is chosen at random from the large nails, what's the probability it's going to be less than 50.1? So it's that divided by the whole sample space, which is 0.75. So the probability is going to be, so this is for D part 1. So for D part 1, it's going to be 0.269938. Notice I'm using all the decimal places so that I'm not doing too early a premature approximation. So we're going to go in here now. We're going to divide that by 0.75. Hit enter and we get 0.3599, which is 0.360 to 3 significant figures. Okay. So what's our next move? Hang on, are we still recording here? Yes, we are. 12 minutes 36. Brilliant. Okay, our next move is the last part. 10 nails are chosen at random from the large nails. Find the probability that at least 2 nails have a length that is less than 50.1. So now we're taking 10 nails from all these large ones, right? 10 nails from all those large ones. And what we're looking for is what's the probability that at least 2 have a length that is less than 50.1. So out of all this sample space here, the probability that it will be less than 50.1 we've just worked out is this 3.360 or 3.359917, 0.359917. That's by the calculator. So that's the probability of success. So what we're after in part 2 is it's a binomial question. It's X is distributed binomially, where we've got 10 trials. The probability of success is 0.359917, and we're looking for the probability that X is greater than or equal to 2. So now we go back into the calculator. We go menu 5. Now we're looking for the, I think it's E, isn't it? The binomial CDF, where we've got the number of trials to be 10. Remember, the binomial is used when there are 2 possible outcomes, and we know the probability of success, and we want to calculate the probability of a certain number of successes. So in this case, the probability of success, I want to put this down in exact form, 0.359917, 0.359917. Alright, we tab across. Our lower bound is 10, because 2. I think we're looking at 10 nails are chosen from the probability that at least 2 nails are chosen, so 2 to 10. So we'll go back in here, 2 to upper bound 10. We tab down to OK and hit enter, and we get 0.924. And so therefore, and that's equal to, 0.924 to 3 SF. And that is the probability that we get at least 2 nails less than 50.1 or between 50.1 and T, which is 48.7. So that's question 9, all about the normal distribution, and it brings in a little binomial at the end there, which is also not unusual for the examiners to do that. Okay, I'm going to pause now, and then we'll look at question 10. Okay, so now to question 10, and what we've got here is a square ABCD and a sector OAB. Part of the square is shaded, so this is R in here, right? So shaded, the area of the square is 2R squared, so we're just looking for this area of this square here. So clearly we need one of the sides. It's going to be AB, isn't it? AB is going to give us a clue. So if we find out what AB is, we'll be right. So AB, now how are we at AB? Well, we've got R here, we've got theta here. So can we use, what's that? Cosine rule? C squared equals A squared plus B squared minus twice AB cos C. Right. So we can do that. So AB squared will equal R squared plus R squared minus 2R cos theta. So that'll be 2R squared minus 2R squared cos theta, which equals 2R squared 1 minus cos, well, that should be a theta there, I don't know what happened there. It's a theta, 2R squared 1 minus cos theta, because AB squared is actually equal to the area of the square, isn't it? So, so therefore, area of the square ABCD is equal to 2R squared 1 minus cos theta. Okay, right, so then we go to, well, when theta is alpha, the area of the square is equal to the area of the sector OAB. Now the sector is this whole thing here, right? So that's the sector area is, what's the sector area equal to? A half R squared theta. Now theta in this case is alpha, so we'll just go half R squared. That's what that is. So write down the area of the sector when theta equals alpha. Well, the area of the sector is just a half R squared theta when theta is alpha. Hence, find alpha. So alpha is going to be the area of the square is equal to the area of the sector. So what we're going to do for B part 1 or part 2 is say that 1/2 R squared alpha is equal to 2R squared 1 minus cos alpha. Now, from that point there, we might say that we can double both sides, or we could just solve that as it stands for put that into the graphics calculator. We could might be just a good idea just to multiply both sides by 2. So R squared alpha equals 4R squared 1 minus cos alpha. Just simplify it a bit. So therefore 4R squared, just looking at that, minus 4R squared cos alpha is equal to R squared alpha. And we might just divide through by R squared. Remember, R has to be positive, so dividing through by R squared is okay. So 4 minus 4 cos alpha minus alpha is equal to 0. Now the way to solve that will be to go into the graphics calculator. 4 minus 4 cos alpha. If we go back into a calculator, or actually no, it's going to be better to graph that, isn't it? So we put in here 4 minus what was it? 4 cos 4 minus 4 cos x, get out of that, minus x. So if we graph that, and then we go looking for menu 6, remember the zeros Here we're looking for the zeros. So there's 1 at 0, 0. I need the next one though. I need the next one, which is at lower bound. I didn't find it. Menu 6, 1. Lower bound there. There's 0.511. So just drag that down. And then the last one will be at menu 6, 1. Lower bound. And 4.57. So 0, 0.511 and 4.57. So therefore, alpha is equal to 0, 0.511 and 4.57. They're the three values you can see where 4 minus 4 cos alpha minus alpha equals 0. Okay, so let's go back to the question and have a look at what values alpha can take. Well, we know that it's got to be between 0.5, I could just look up here, between 0.5, where is it? There it is, 0.5 and pi, which is 3.14. So we can get rid of this one and this one. So there's my value. Alpha must be equal to 0.511. Okay, last part, C. And C is requiring us to do this. When theta is beta, the area of R, now this is the area of R, not the square, but R. The area of R is more than twice the area of the sector. So we need the area of R. Now the area of R is going to be the square. So R is going to be called the square. So we worked out the area of the square. It was this. It's 2R squared, 1 minus cos. Now we're going to use beta in this case. We're going to go to beta, cos beta. So that's the area of the square. Now, so we have to subtract this little area in here. Now, what's that equal to? I'm going to have to go to the second line, because this is equal to the area of the sector minus the area of the triangle, which is, the area of the sector is half r squared beta. That's the sector. The area of the triangle is a half r squared sine beta. Half r squared sine beta. So r is going to be equal to the square minus this minus this. So that gives me this little segment area here. So we simplify all this, we get r is equal to, you run that through there, and we get 2r squared minus 2r squared cos beta. Alright, so we get 2r squared minus 2r squared cos beta minus a half r squared beta plus a half r squared sine beta. Okay, so that's r. That's huge. Now that's that is more than twice the area of the sector. Remember, the sector area is just a half r squared beta. So 2r squared minus, now we need to write this all down, 2r squared minus 2r squared need to come down here somewhere. Alright, so 2r squared minus 2r squared cos beta, what was minus a half r squared beta, minus 1/2 r squared beta, plus a half r squared sine beta, plus 1/2 r squared sine beta. Remember, that's just r, that's just the r area, so that has to be greater than, more than twice the area of the sector. Twice the area of the sector. The sector area is 1/2 r squared beta. Alright, we're solving this. All right, let's do a bit of sorting. Okay, well, this just turns into r squared beta once you've worked that out. And now there's an r squared beta here. So we'll end up with 2r squared minus 2r squared cos beta minus half r squared beta. We're going to bring this one over, so it'll be minus 1/2 r squared beta. All right, so that'll go down to 0 now. So I've taken that over. All right, plus 1/2 r squared sine beta, all that to be greater than 0. Now we could look at r squared. We could divide through by r squared. So therefore 2 minus 2 cos beta minus 3 over 2 beta plus 1/2 sine beta is greater than 0. Alright, so that's where we're at. Now it's time to go and put all that into here. Alright, we need a new control N for a new. Do I want to save? No, I don't. We'll have a graph, thank you. Alright, so in here we're going to write 2 minus 2 cos x, 2 minus 2 cos x, minus, alright, in we go with a fraction, 3 over 2 minus 3 over 2 x plus 1/2 sine x plus another fraction, 1 over, put that back in there, 1 over 2 half sine x, 1/2 sine x. Okay, now if we hit enter there, we get this graph here. Now what are we doing? We're trying to find out where this graph here, where this function is greater than 0, so where it's above the x-axis, where is it greater than there 0? So we need to find out, let's get rid of that label that's in the way, need to find it. So it looks like, let's find out menu 6.1 where it's crossing the axis. So it looks like it's 0, 0, good. Menu 6.1, right, where else is it? Let's find out where it's 0, 0, good. 1.31, there it is. And menu 6.1, go back in and find out where, there, get rid of that. And 2.67. So, where is it greater than 0? Well, less than 0, but that's not in our domain. Under here, so it's between, it looks like it's greater than 0 between 1.31 and 2.67, which are both within our domain. So therefore, between 1.31 and 2.67 are our values of beta that solve that inequality. Righto, so that's a bit epic. That's a 27-minute YouTube for 2 questions. Please mark it. Oh, sorry, I've marked it for you. Please review that and get what you can from it, and then perhaps follow up with some questions, and then hopefully that helps you going forward. Okay, see you soon.